Leo, should we start, right? Yeah, I suggest. Okay, welcome everyone. I'm so glad that so many of you could join us this evening. From my side, I hope this workshop will serve you as a great opportunity to learn a lot of new stuff about AI and its application. But before we talk about organization and lecture itself, I want to give a word to the co-president of TombAi, Toby. Welcome, Toby.
Hey, David. Hi, all together. As David already mentioned, I will provide you with a few words about TombAi. And for this, I have a few slides prepared. So first of all, my name is Toby. I'm one of the 3 presidents of TombAi. And for me, it's actually a huge pleasure to be here and to give the opening words about this AI entrepreneurship lab. And I think this is a quite cool opportunity because one of your colleagues, or Bang, reached out to us some months ago, and we had this idea about this collaboration, and I never thought that this comes true so soon. Even by the end of this year, thanks to the great organization by by many of our TombAi members and the involved Americans. So let's start with a short introduction about TombAi. So the organization you are dealing with the next 2 weeks. So what is TombAi actually? So TombAi is a student initiative, and a student initiative, maybe you have similar concepts in Ghana, is a club managed and led by students. And we are supported by the Technical University of Munich. And actually, we are the leading AI student initiative in Germany. The second point is we are a non-profit organization, meaning that we are not profit-oriented like other companies. And the third point is we have a clear AI focus. So in the field of AI, we want to bridge the gap between theory and practice. So we always have this hands-on mentality. And I also want to give you some key facts about TombAi. So the first fact is we have about 100 active members, and the new ones will join in a couple of days. And active really means, okay, they have a time commitment per week from 4 hours ranging to, let's say, 40 hours. And I think our main organizers can tell you what time commitment is. And the second key fact is we have 25 plus partners and collaborations. So for example, we already partnered with Google, Microsoft, IBM, or OpenAI. In our initiative, we have 15 plus different majors. So the majority of our students have a technical background. So they study, for example, informatics related subjects, but we also have management students, medicine students, or marketing students. Also, we have 150 applications per semester or even more. And based on these applications, we select the best 25% and they are able to join our club. And as already mentioned, we have a high tech background, but that number, the 70%, also shows us that we have 30% non-techies, because at the end of the day, this is not a one-man show ruled by AI experts. We really seek diversity. We need also management students with a business background or domain experts, right? Politics students, medicine students, or law students. And the last fact is that 70% of our members, or even a bit more, already graduated. So they have their bachelor's degree, and right now they are in their master's or even make their PhD. So these were the main facts about TombAi. And now let me switch over to the AI Entrepreneurship Lab. And first of all, I want to make clear that this is a new and innovative format. TombAi at the moment offers 3 signature projects. So the first one is called a Megathon. It's similar to a hackathon, and it's always also quite new. So in terms of AI, but hackathons already exist. The second one are called industry projects. Here our students tackle challenges provided by companies over a course of 8 weeks and deepen their AI knowledge and also develop AI products. But the last one, this AI Entrepreneurship Lab, is probably the most innovative signature project. And let me tell you this, that we found quite less resources on the web about similar concepts. So this is actually a quite new and innovative format. which we want to offer here. And this concept is basically divided into 3 steps. So the very first step is you will learn about AI. So you will learn about the very, very high level concepts about AI. And in the second step, you will define a problem. And by doing so, you will clarify 2 questions. The first one is, could AI solve this problem? So this means, is it feasible to solve this problem with AI at all? The second question is, should AI solve these problems? So are there better solutions, or is AI really the perfect solution? And this is in terms of, for example, deploying it, right? So do you have a stable internet connection, or is this required? Is it required that the system is capable of being real time and so on? Or is it trustworthy for safety critical systems? So should AI solve these problems? And then if you have a feasible and a useful AI use case, then you have your final deliverable in the third step. And this concept of the entrepreneurship lab, this first iteration will be in collaboration with you. So the Innovation Center of the KNUST in Ghana. And the cool thing is so that you have your vision, right, which motivates you, which is the long-term goal and the motivation why you wake up every day and you are so motivated, right? And we have our vision as a club, which motivates us. And the combined vision between your club and our club could be look like the following. So we want to create AI-based products and concepts that create a better everyday life for Africans while churning out world-class engineers. So that could be our combined vision for this project, which really, really motivates us. And the first point is clear, right? It's all about AI in this project. And the second point here, which I want to emphasize, is they're churning out world-class engineers. So the first point is really cool that we have to churn out world-class engineers, you need diversity. This is not a one-man show. So we need you guys. You have the engineering background, the engineering knowledge, and you also have the domain knowledge. You know what's going on in Ghana and Africa. And we can provide the AI expertise. And together, we can develop really, really strong and feasible and useful AI use cases. So this is the first point. And the second point is also, it's not all about theory, right? If you want to be an engineer, you have to get your hands dirty. So we also have this hands-on mentality. This is not all about theory. This is also about practice. So doing ideation, doing brainstorming, developing real-life use cases which create a better everyday life for Africans. And at the end of the day, we all together can become world-class engineers. So how to reach out to us. If you want to stay up to date, follow us on LinkedIn, follow us on Instagram. You can contact us via our email address or follow us or check out our website if you're interested in TUM.ai. And I think the slides will be shared afterwards, so you can check out the links afterwards. And with that being said, I wish you all the best for the upcoming 2 weeks. And I'm really, really looking forward to the pitches next week, Friday. And yeah, so with that being said, I hand over to David and see you soon. See you soon.
Great, great introduction, Toby. Thank you very much. And now to my slides, I guess, if you give me a second. Yeah, just to be sure, guys. And Fox, do you see my screen? Some kind of reaction? Yeah, I hope so, right? Okay, then, yeah. So let's continue. Now I want to give a word about myself before we dive deep into introduction to AI and organizational stuff. My name is David. I'm currently a bachelor student pursuing information systems degree at TUM in Munich. I joined TombAi approximately 1 year ago, last December. And so far you can see I enjoyed greatly. We have great stuff with Toby, with Patrick, Flora, and other teammates from TombAi. Especially like maybe you've heard about makeathons and now industry projects and TombAi e-labs, starting with you guys. Okay, And now let's talk a bit about lame stuff, organization. I want to start by schedule of our weeks. First of all, we have this lecture, which will last around 1.5 hours. We just extra 30 minutes for having an extended Q&A session right at the end. And tomorrow and on Wednesday, we will have another 2 lectures. More about that in a bit. On Thursday, you will have a code spare day, which you can use to complete assignments, which you have to submit on Friday. Again, about that in a second. So yeah, you can take a look right now. I will share all the slides afterwards, so don't worry. Yeah, how can you actually participate during the venture week? As you might have heard, we have around 450 applicants for this workshop, which is huge. But due to our limited human resources, we can only directly work with around 185 students. That is why we have created some requirements for participating in the second week. First of all, you can see that you would need to complete all 3 assignments until Friday. These assignments will be presented to you as Google Form quizzes and are purely based on the content of our lectures. And later, after the third lecture, we'll ask you to complete a motivation form. More information will follow on Wednesday. Okay, regarding communication, as you have already experienced, we announce all the important information in our Slack. And I mean like all the important information. So be sure to check it out at least twice a day, in the noon and in the evening. And if you experience any kind of issues, write them in our AI Week support channel. And if you want any questions regarding this lecture, be sure to ask them in the AI lectures Q&A channel. And Daniel will answer them. And the most interesting questions I'll answer at the end. Yeah. And yeah, any further information you can find on our Notion page. Link is in the Slack as well. And now let's talk about an education week. What can you expect from it? First of all, we'll have 3 lectures, namely Practical AI Overview, which we will cover today, Evaluating AI. Laura will present it to you tomorrow. And last but not the least, Patrick will tell you about developing AI use cases. Besides that, after each lecture, we'll have an assignment which we were talking about. And now let's not delay further and dive deep into today's topic, Introduction to AI and its Practical Overview. Yeah, so we'll start quite slowly with an introduction and some basic examples. But afterwards, we'll talk about machine learning. Then we'll have a small overview of some of AI fields and continue to talking about computer vision, natural language processing, and time series forecasting. So what is an AI? What examples of AI can you see in your everyday life? I think you might be familiar with self-driving cars like Tesla or voice assistants like Siri or Alexa, which is quite common this day because of different factors like extremely fast innovation from minds around the world. And yeah, you might as well heard about fraud detection in financial transactions. Or maybe you have used Netflix or any other similar service to stream your favorite series. Then, and of course, how can we forget about Facebook and all other social networks like Instagram, YouTube, etc. Or a safe or a lifesaver like Google Translator. I have used it thousands of times before learning English or German, so I can recommend to you as well. Yeah, and I guess let's start with a ML introduction. Some points we will discuss today during this topic. What is machine learning, and what is the learning behind the machine learning? Yeah. So let's start. We'll talk about 2 approaches to AI. The first one is being rule-based AI, the more traditional one, so to say. Basically, when you hard-code your intelligence. In this case, you define the rules by hand. And as an example, I can take maze solver. Maybe you've heard about solving maze with the right-hand rule. It's quite deterministic if it has a solution, but it's also considered an AI in this case. One cons of using rule-based AI is you have to define all the rules by hand, and it's very cumbersome. It's really extremely hard to scale. So you can imagine the hassle in this case. An anti-example from my side could be distinguishing cats and dogs. It's just not feasible to hard code it. You have thousands of pixels, and there are like a lot of ways to solve it, but not with the rule-based AI, so to say. On the other hand, like pros of rule-based AI is you don't need a lot of data in your projects. On the contrary of machine learning, which we'll talk about now. Yeah, so another approach to AI is machine learning. The pipeline is pretty general for all kind of machine learning models, algorithms. You have data, basically a lot of data. In some cases, it can take even 2 terabytes of data to just approximate the function, the model, and the final model. Then you have a learning algorithm. It's purely mathematical approach to solving AI, as you can see. Then you have a probabilistic output. If you remember in the AI-based output, not AI-based output, but rule-based AI, you have a deterministic output. So, for example, in maze solver, you would have either you have an exit to the maze or you don't have an exit to the maze. In probabilistic output, you don't actually have a deterministic output in most cases. For example, distinguishing between cats and dogs. You can say the probability, the picture being cat. Sometimes it can reach something close to 100%, but basically always a probabilistic output. Yeah, another thing with machine learning is that it has higher margin of error because we still haven't reached the general AI, so to say, which can solve all the problems. So you can imagine we would have higher margin of error because humans make errors as well, even in detecting some kind of things like a cat in the horizon. It's even hard for us. So you would expect a high error. And it's more biased because it heavily depends on data we already have, which also includes the human-based data, which, as you know, have a lot of biases in it. Yeah. Now let's talk about learning types. In machine learning, we distinguish between a lot of actually learning types, but we'll cover only 3 today, being the supervised, unsupervised, and reinforcement learning. Supervised learning is basically when you think about supervised learning, you should imagine it as a function which maps given data X to a given output Y. Again, example of cats and dogs. It's basically a supervised learning. You have a picture of cat, and you want the model, the machine learning algorithm, to tell whether it's a cat or a dog. It will give ability, but it's still an output. Yeah, basically finding a function f of x is the idea of supervised learning. Another example of supervised learning, no, not example, but a subclass of supervised learning is classification. Like we've talked about cats and dogs, right? Here we have whether a person wears a mask or not. It's basically the main purpose of classification is to give an output, a probabilistic output on a discrete class of answers. A multi-discrete classification problem could be, for example, you have a picture, right? And now you don't distinguish not only between cats and dogs, but also horses, sea lions, and other animals, and humans, for example. There you can have as many classes as possible, but they are discrete. You can count them, so to say. On the contrary, we have a supervised learning. We have supervised learning with regression. A very simple example of it is a linear regression model, where you just want to fit a line for the given data points. Here you don't basically have classification classes. You just have a continuous function that you want to predict. As an example, you can take housing price prediction. You have a function of area in the bottom, and you have price in dollars, which you predict. Yeah. Basically, you find an f of x, which is mapping not to discrete classes, but rather like continuous space, like R or complex numbers, for example, right? Another type of learning is unsupervised learning, and we will start with clustering. The idea of unsupervised learning is to have no for your given data whatsoever. For example, you have a lot of pictures of cats and dogs this time, but you can't possibly name them all because it would take you days, for instance, right? You have, for example, you have million cats and million dogs, picture of dogs. I mean, it's just practically impossible for a person to do it alone. So what people have come up with is doing clustering. When you, for example, and this kind of learning will distinguish cats from dogs, but it won't give the names of those classes because it doesn't know what a cat or what a dog is, but it knows it's different in this case. Yeah, again, another example could be a customer segmentation. We have a 2D map actually this time, location and income, as you can see on the bottom on the left. And we have, for example, 3 different clusters: medium income, good location, high income, also good location. Yeah, it's like this. And now let's talk about reinforcement learning. The idea of reinforcement learning is for the agent to learn the best actions based on its environment and rewards the agent receives during its actions. We can have a very good example is that you want to program a Pac-Man to win. Basically, as an action, you would have moves up, left, down, and as a reward, which also can be negative, you receive points. For example, when you eat a yellow dot, you receive 100 points, for instance, right? And then for example, when you encounter a ghost, you receive minus 1,000 points. And the idea of this reinforcement learning is to learn the best actions, like to learn the best rules to follow. In this case, for example, it would be eat as many yellow points as possible and avoid ghosts at any time. Yeah. Now let's talk about how can you actually obtain a model in supervised manner. For supervised learning, you also need data, with input data as well as label. Again, in our case, pictures of cats and dogs, and output would be a label of whether it's a cat or a dog. Then you have a model, which is just a function. Again, you just have to imagine it being a huge, maybe it should be a huge function. We don't know at this point. It can be whatever you want. Yeah, it could be whatever function you need for this kind of problem. With the help of optimization, you try to increase the loss. Like, for example, if the model says that this picture of dog is a cat, it receives a negative, not a reward, basically, but it receives a bigger loss because it's not a dog, it's not a cat, it's basically a dog, a picture of dog. And we want this model to learn this. And how can it learn it? It can compare it to the real answer. In this case, it would be a cat, answer cat. And then give a feedback. In this case, improve the parameters of our function. Yeah. So another important thing for a model is to see a lot of data, like I've told you, because only on 2 pictures of dogs and cats, it can't really learn all the complexity of cat being a cat, being a dog, because it's not, it doesn't have human sensors. But if you think, when you scan, for example, a cat or a dog, you have a lot of information, a lot of pre-processing information going on inside your brain. You just don't pay attention to it. But in the case of function, a model from a computer model, it doesn't have a lot of pre-processing, unless you do it, of course. So you have to rely on the data in this case. Yeah. Now let's talk about AI fields. As you might see, AI is quite, it has wide variety of applications like natural language processing, recommender systems, computer vision, and speaking about like fields, like applied fields, physics, robotics, medicine, biology, and many, many more. In this lecture, we'll cover three varieties, so to say, namely NLP, natural language processing, computer vision, and time series. Some examples of for each of this type. First of all, for computer vision, we have face mask recognition, like we've talked before. For recommender systems, would have Netflix suggestions. Based on your preferences, it gives you the best recommendations, namely hence the name recommender systems. And for example, we have Google Translator, basically a machine translation. For time series, we have stock price prediction. For medicine, biology, we have protein folding. Maybe you've heard about the recent discoveries about protein folding, which is turning the just amazing what can we achieve with AI in this case. And then for robotics, we have self-driving cars like Tesla, this kind of stuff. And for physics, we have, for example, CERN. Yeah, AI can be applied everywhere, and sometimes it's even hard to distinguish and categorize, but we can try. Let's start with computer vision. So yeah, computer vision deals with letting machines process and analyze visual input. Similar to human vision, it processes light input using eyes. So, for example, human would use light as input and would process it with their eyes and brain. But as I've talked before, brain processes the data implicitly sometimes. And it's not really the case for computer vision in many cases, in many times, right? so computer vision tries to imitate human vision with cameras, sensors, capture visual inputs similar to eyes. And algorithm process the input and perform tasks similar to the human brain. Again, you have to code the pre-processing in this case. And then in any case, you would receive some kind of output. It could be a classification. It can also be regression, and many different types of machine learning algorithms and models. Yeah, computer vision is huge by itself. We have three depots estimations, scene reconstruction, many other topics like image and video classification, object detection, object tracking, image captioning, instance segmentation, semantic segmentation. Man, yeah, we'll actually cover all the green points today in the lecture, starting with image and video classification. Yeah, image. For image and video classification, we have, again, cats and dogs. Everlasting example. We have an image of dog, and we try to recognize an object. In this case, it could be a dog, it could be a cat, but with some kind of probability, we say that, with some kind of certainty, we say that it is a dog. Algorithms try to recognize this. So this classification, computer vision algorithms try to recognize whether one object of the class is present in the image or not. In this case, it's more than or not. It's mainly which class it is. But yeah, as I have already said, image classification mainly focuses on recognizing objects. But for video, we have another kind of approach. As you might know, video is just a lot of pictures. And in this case, algorithms try to recognize which action from a fixed set of action is performed in the input video. Like, for example, swimming, running, eating, jumping, standing, etc. And yeah, video classification mainly focuses on recognizing actions. Sometimes objects as well, but it's subtask, I would say. Like for example here, object detection. Object detection tries to locate objects either in an input image or in a video. If an object is if an object is found, it wraps it in a bounding box, for example, or additionally, it also tries to predict the class of the object. As you can see here, it predicted a dog down below, car on the right side, and traffic light as well on the top right corner. And it also often gives a confident score for the class label, which we'll talk about in a minute. Yeah, talking about videos, object tracking. So basically, only videos work as an input for object tracking because it doesn't make sense to track objects in one picture. I might be mistaken, really, but yeah. Videos can be split up into frames, which is nothing more than a picture at some point in time, like I've already told about that. Here we have, for example, video frame at time t, and then we have a video frame at time t+1. Yeah, similar to object tracking, it detects whether an object is present and puts again a bounding box, like you can see a blue box, an orange box, a green one, and puts a bounding box around the object. Then, over the different frames, it tries to keep track of previously detected objects. Yeah, I guess it's self-explanatory in this case. Yeah, let's now talk about semantic segmentation. As you can see, we have an input as an image or video, and our idea is to basically label each pixel. It can handle image, video inputs, right? And it also holds for video frames some time t and a predefined grid of pixels. Semantic segmentation tries to label each pixel in an image or video frame for the class. What I mean by this, we have, for example, here grass or skies or sky or cow. As you can see, it doesn't differentiate between objects. For example, there is no border between the cows. It's not the idea of semantic segmentation, but rather as instance segmentation, which we'll talk in a bit. It does not care whether something is an object or not. For example, like sky. It just tries to segmentate. That's the idea. Because we do not care about objects. The dataset must also contain class labels for backgrounds such as sky, grass, and etc. But on the contrary, instance segmentation. It's at first sight, it's similar to semantic segmentation. However, the word instance already hints that we care exclusively about objects now. We color all these pixels of the same object in the same color and label them. This implies that we put a border between distinct objects of the same class, like in this case, cow. So, yeah, and we don't have, for example, we don't need to care about sky, grass, and this kind of background if it's not intended output. And again, it can be done for image and videos. Let's talk about image captioning. Image captioning deals with answering the following question: what does an image show? In the first case, we have, for example, two men walking on the beach, and we want to generate a caption. Two people walking on the beach with surfboards. Perfect. So it tries to describe it in natural language. It tries to describe the picture in actual language setting. And the description of the image we call it most of the times caption. But let's take a look at the second example. So we can see here that that's a prominent example of an AI making a mistake in the prediction. We clearly can see that a man is not throwing a ball, but rather tries to catch it. That's the problem. The problem with that is that AI does not understand physics. Every human can infer that from the jumping position, nobody could throw a ball, and therefore the guy definitely tries to catch the ball, not throw it. Most likely, the datasets didn't contain more images of baseball players throwing instead of catching. And that's actually, again, speaking about the amount of data. You have to try to include as diverse data as possible. and try to capture as many cases as possible again. And yeah, hence the lack of understanding of physics and the missing catching images led to a higher probability for throwing. Yeah, actually a good example for how AI thinks in this case. It just thinks about only about those instances that you have provided you with it. Okay, now it's time for an example demo, so to say. If you give me some time, I'll switch to my other screen, and we will talk about examples. Yeah. Yeah. Just a confirmation from your side, guys. Do you see everything what I'm seeing?
Yes.
Cool. Nice. Let's talk about object detection in instance segmentation in practice. So we have a Detectron 2. It's quite, give me a second. Safe. It's a huge model by Facebook. I guess it's a meta right now already. You can find the link in here. Daniel will send you a Colab link so you could try it yourself afterwards if you want. Anyway, yeah. In the meantime, while we're waiting for the setup and the installation, I guess maybe we have some questions, Daniel.
No, we don't have any questions so far.
Okay, great. Yeah, again, if you have any questions, just ask them in the third channel. Daniel will try to answer them, and we'll have some in the end. Damn, it takes so long. Yeah. Would have prepared this, I guess. Oh no. Yeah. So yeah, basically this model is going to show you the example of how instance and object segmentation and detection works. And you will see quite interesting results as well. I think you like what we will see if we will get to this. Anyways. Yeah, I think we're ready to go. No, what's wrong? My bad. Yeah. We'll have this here. Yeah, we have first to define the function for inference, which will make our life much easier in this case. So in our case, we'll have inference on MC Coco dataset using a pre-trained Detectron 2 model. It has a lot of classes like person, snowboard, cup, bird. I mean, you name it. Yeah. After the model sets up, yeah, we have our first example. So let's get the first example. So we'll download the image. And afterwards, we'll try to distinguish it. Yeah, so you see, so from the first glance, you have a horse here with a man with a lot of people, rainbow, well as trees. And let's try to run inference on this. Inference is basically trying to using model on a given data object. And as you can see, it detected a lot of persons. Even in this case, it's quite amusing that it recognizes it as a person, even if the probability is not that high. I mean, around 66%. But still, you can see it's doing quite good. Person 100%, umbrella 180%. Yeah, that's the idea of object detection and instance segmentation. Now let's go with a random example from Google Airplane. Yeah, we have an airplane, nothing particular. It's quite an easy image to detect and categorize. Let's see what it does. Again, it detects airplane with 99% accuracy. But as you can see, sometimes even models can have errors, like we talk about that. It didn't detect the boundaries of an object exactly correctly, because you can see it didn't include this wing, and then it ignored for some reason this part of the airplane here as well, and then it has some kind of funky borders. It just tells us about that. Even models has it thoughts, so to say, about the object. And let's go with the last example. Random, city traffic. We will wait for it for a second. Damn, it takes so long. Okay, that's a huge picture. I hope I can fit it in my screen. As you can see, we have a hell lot of people, bikes, taxis, cars, traffic lights, you name it. But then if we call our model it, let's see how it performs in this case. You see, because the data we are giving right now is quite detailed, so the picture is big. So it's like the processing time of the inference time of the picture itself takes so long. You can see it detected a lot of objects like bus, cars, handbag, even handbag, man. Yeah, but as you can see, it didn't detect all of traffic lights. Error of AI, which we have to consider when we develop, when we use AI in real life, because it has its downsides as well. Because, like in this case, it doesn't detect everything because it just ignored for some reason. It just doesn't think it's an object or any other reason behind that. Yeah, that's it for the demonstration of the model from Facebook. And now let's go back to the slides. And you must see it here, right? Give me a second. Yeah. So let's go to natural language processing. If a person reads or hears a natural language, the human brain processes the data and performs different tasks implicitly. For example, speaking in different language refers to translation, or reading a text message from a friend and inferring from the text whether it has a positive, neutral, or negative mood. Yeah, basically when you receive a text from your mom about not being at home at 10 p.m., you can definitely tell the mood about that. Or have natural language processing. But on contrary, natural language processing with computers also deals with understanding and processing natural language in a similar way to how humans do it. But unlike humans, they perform the tasks explicitly. And that's an important point, actually. Again, the human brain is, in this case, is replaced by algorithms or computer machine learning. Yeah. So what is NLP? Again, NLP is a huge field of AI. It includes machine translation, dependency parsing, text classification, sentiment analysis, text generation, and a whole lot of different other topics. It's just huge, and it actually it's still in development, the whole NLP area. Every day you can learn about state-of-the-art models about natural language processing. Yeah, my bad. We'll talk about all the green ones today, starting with text classification. Yeah, so text classification. Basically, the idea is the same like with the general classification, but in our case we have a message. In this case, it's just sorry, I'll call you later, and in our example, we try to understand whether it's a spam or not. Basically, giving it a label yes or no. As you can see, input is just natural language in form of a text, right? But with try to assign a class to it, basically like in a classification problem. Or you can see, as a human, you can definitely understand that that's a spam. Congrats, 1 year special cinema pass for 2 is yours. Call blah blah blah. Yeah, you can definitely say that's spam. You can also a multi-class classification problem, a natural text classification problem would be, for example, mood, determining the mood. Sorry, I will call you later, and you want trying to understand the mood of this text. It can be negative, positive, disgust. I mean, nervous, all kind of stuff. Yeah, let's talk about sentiment analysis now. The basic idea of sentiment analysis is try to classify the mood of some text. Yeah, it kind of intercepts with classification, text classification to some degree. It can also be described as a specialization of text classification, right? Yeah, it typically has the 3 labels: positive, negative, neutral. But in some cases, like in ours, it can have mood labels like negative, positive, neutral, nervous, etc., etc. And again, example about Tesla crash. Given it like a news from Tesla's involving Tesla, we try to understand, is it like a negative or a positive news? Maybe you could use this information for tracking your stocks. Actually, quite a good idea. You can rely not only on numbers, but also, as you might know, stocks and market is also relies on humans' behavior, not only on numbers and accounting. So yeah, in this case, it, for example, detected words like critic and crash, which might, based on context, of course, indicate the negativity of the text. Yeah, let's go to text generation. GitHub Copilot. So text generation, given some initial context, text generation tries to extend the text further with AI, which the AI thinks fits into the given context. Actually, I would like to give you another demo of Codex. I think Applied.ai won't sue me for this. And the code of words as well. If you give me a second, I'll switch back to screen. Yeah. Again, I hope you can see everything here. And we'll start. Yeah, we will start with a simple, very, very simple. It's not mine. We'll start with a simple example. Maybe some of you have heard about Code Wars. You can actually visit them. It's basically a website which gives you some kind of information about this task, description, like what do you have to do, and have to give a solution. In this case, it's a very simple task. You just have to create a simple function. But it can show some aspects of machine learning in this case. If you give me a second. Yeah, I have already like inputted the text here from the website, so we could save a bit of time. The idea is the following: given a number num, turn the shortest amount of steps it would take from 1 to land exactly on that number. I mean, we can take about, for example, number 3. It would take 2 steps, and steps are defined this way: either adding one to the number, or doubling the number. Pretty basic setup, but quite interesting to try it with machine learning and AI. With number 12, we would have, for example, 4. So you have to first of all add 1. You have to add 1 to 1. You would receive 2. Then you have to add another 1 to receive 3. Yeah, then you multiply 3 by 2. You have 6, and at the end you have 6 by 2, 12. You also always start with number 1, and you have to reach this number. Yeah, let's give it a try. I just copy pasted the explanation here with some tweaks. I just I just deleted the description part, but example one of example made the examples more clear. So we have a description of a text, and we have a basic setup for our function. So let's see what it actually generates. As you can see, it took less than 2 seconds, I guess. And let's try this function as a solution. Yeah, so this is our solution. We can test it. As you can see, it tests fast, and then we can send an attempt. As you can see, the results are astonishing. You have passed all the tests, not me, but I guess in this case. So if you want to cheat, which I don't recommend you can actually use this. But another example I would like to show you is basically a pretty basic code generation, so to say. Yeah, I'll just start with this. We have our load. I ask the machine learning model to load an iris dataset from scale-learn dataset. It's basically a very simple dataset which includes different kinds of. And the idea of this hello world dataset is to try to build a simple machine learning models based on it. So let's do it. So first of all, I ask it to load iris dataset. Okay. Actually, this is a good example of machine learning, not a model being too making model to overthink. Yeah, we just need this part, and if I just copy and paste it, let's test it out here. It works. Now I want to proceed with the next quote, which is to plot. I want to see the data on my hands. So let's ask it. Take some time. Let's see if it works. Yeah, as you can see, it just plotted the data for us. Kind of magic if you would think about that. In this case, it also takes into account the data, the text before it. Basically, it knows we're dealing with iris dataset, and it knows that we have already downloaded iris dataset to this iris object. And it, as you can see, it uses it somewhere here. Yeah, it uses it to get data. Then let's imagine I would like, I don't know, let's split the data. I want to have training and test data for my model. Yeah, I'll write it like this. Split the data, iris data, into test, training, and test. Let's see what it does this time. Again, it's quite simple, but it's still fascinating that it can do this. For example, we have from scikit-learn, the library for basic machine learning. It tries to split the data. So in our case, it's just X and Y's because it's supervised learning, supervised classification. As you can see here, we have distinguishable classes, basically, namely 3 of them: Virginica, Vesicolor, and Setosa. And we want to try to learn a model based on it, based on this data. Yeah. Yeah, we can continue with this, but I think you get the idea so far. Yeah, that's about codecs. We will actually return to this playground in a bit. Let me first of all switch to my presentation. Mirroring. Yeah, and you might see my Yeah, I guess you could see. Nope. Yeah, let's go back to it. Yeah, that was a text generation. Text generation also includes code generation because it's a natural language processing after all. It can have any kind of text. But let's talk about named entity recognition. The idea behind this is to try to detect entities in some text. Like, for example, we have a text from Wikipedia about Albert Einstein, and we want to see what does it include in it, what this text is talking about. As you can see, it has person, it has dates, like 6 weeks later, March. It has locations like Germany, Munich, yeah, Zurich, and organization. Like, again, it really depends on what you're trying to achieve. In this case, we want to see if it contains anything from this set of predefined labels. But it can be whatever you want. It can be food. It could be, for example, a recipe which includes reference to people, food, ingredients, you name it. Let's jump to speech to text and text to speech, right? Again, the idea is really simple. You have audio data, and you want to translate it into text data. We have a lot of bots in Telegram, for example, which can translate sometimes annoying audio messages which you can't hear, for example, during the lecture, into text data, and you can actually take a look at them at the text and just reply with the text. And you can do vice versa. For example, you want, when you talk to Siri, right? What it actually does, you kind of a Siri backend of Siri generates text response, and then iPhone, with the help of AI, of course, and machine learning, tries to generate audio data out of this. And again, vice versa. You're telling something to Siri, and she then translates this audio to text. Yeah. Yeah, let's go. And then now I want to talk about another text generation. SOTA example, which stands for state of the art example, which is a funky word, if you would ask me. And it's really used more than it should be in a lot of papers. Yeah, and what you have just saw with GPT-3 was a codex representation of it. Codex is actually based on GPT-3 with some tweaks from OpenAI. And now we'll talk about GPT-3 itself. Again, I have to switch to my screen. Yeah. Boom, boom. Let's go to the quite simple example of horror story. Yeah, don't look at those now. They won't make a lot of sense, but the idea is really basic. You give some kind of prompts, the machine learning model, in this case it's GPT-3, DaVinci, and you want a school, and you want as an output a 2-sentence horror story. Okay. Whoa. Not stream safe. Let's do it like this. It's actually kind of a problem sometimes. Again, bias. It's all based on human text, but I can assure you that it's a text internet have never seen before. Maybe to some degree, right? Because it doesn't copy information from data. It generates a new one. Yeah, I could add it to words, but as you can see, I mean, gets a 2-sentence horror story, so to say. It can even count. Yeah, nice. Yeah, that's about horror story. Let's talk about customer service. I want to save it actually. Let's talk about customer service. Yeah, we have, for example, a question. Dear customer support, I'm quite unhappy with my last order. The phone which I ordered arrived broken and the charging cable is also missing. Let's see what it will generate to this question. Maybe I can answer some questions like this as well. Yeah, as you already can see the problem. Because it's based on some kind of data, it sometimes includes the data from internet, which it was trained on. Like, for example, dear customer, we apologize for the inconvenience caused. Please contact us, customer service department via this email. Yeah. Actually, it can also generate a quite good essays, but I won't show it to you because it would be a cheating again. Yeah. And one last example I want to show you is grammatical standard English. Yeah. Sentence. She went to the market. I mean, even I speak some. And then we have standard American English. See how it does it. She didn't go to the market. Again, pretty simple example, but you can see the potential with all of this. And that was all about GPT-3. Again, we'll post a lot more links afterwards. You can read about it. Yeah. Let's go back to the streaming presentation. Yeah. Something it could also do is like explain to a child. For example, you have a huge paragraph, which you don't want to explain to your kid yourself. Ask AI. I mean, it's so universal, man. And we are finally getting to time series forecasting. Time series. How should I start actually with this? So we have time series data, which is just which can be divided into univariate and multivariate. Let's talk, for example, let's start with the univariate time series forecasting. We have, for example, time, right? As our variable, and we want to predict solely on our time. We want to predict weather in Munich tomorrow. It can learn based on previous years, previous time data, how actually Munich behaves weather-wise during this time of the year. Yeah, this is quite a simple example, but it shows how time series works. The main idea of time series is to use it for forecasting. Yeah, which we'll talk about right now. Again, we have a month. And now let's talk about another example is airline passengers prediction. We want to predict how many passengers we would have at this time. At this time of the year. We have one variable time, in this case month, and we have one output variable, which is not variable, output, which is passenger. Yeah. Again, univariate just means that you have time series with single variable, and because how the behavior of the same variable, how it will behave in the future. Yeah, let's go to the next one, a bit more complicated one. I mean, the idea is the same, but it's the multivariate time series forecasting, which again means having multiple variables to work with. Yeah, the idea is that the variables correlate and support the forecasting of the target variable. In this case, it would be heating energy consumption. We have an output of room temperature. No, not room temperature, but energy consumption, right? And we have an input of outside temperature, of room temperature, of heating energy consumption. Yeah. So also note that what do I want to say? Yeah, and it takes into account all kind of information from different variables we talked about and try to forecast the energy in this case. An important point to mention is that there are always some kind of seasonality in the data, and we can always see the effect of seasonal effects. For example, you definitely know that in January you would need heating in most places, right? And then, for example, in July you definitely don't need any heatings. Hence, the energy consumption during those kind of months really isn't that high as, for example, again in January in Munich, as for instance. Yeah, for example, in winter, high energy consumption. In spring, energy consumption decreases with time, and summer would have low energy consumption, and in autumn energy consumption again increases due to the cold weather. That's it for now. If you have any questions, I am more than glad to answer them. We are right on time, 30 minutes earlier post. I just want to thank you for your attention, who made it so far. And yeah, time for the question.
Yeah, David, thank you for your presentation. There are no questions so far.
Okay.
Someone is just writing into the Slack channel, so just wait.
Okay. I mean, if there are not a lot of questions afterwards, you can just end it here, and you can ask your questions in AI Week support.
There is one question here in the chat. So basically, AI is all about coding.
This was the question, right? No, AI is coding. It's also about choosing the data, right? It's also about making some assumptions about the data. I would even say it's more about data than code, because you can code nowadays. You can code machine learning AI with, I don't even exaggerate, like 10 lines of code, and you will actually see some of those examples during the third lecture. During the third lecture by Patrick, you'll see how easy it is actually. In my case, for example, I don't show you anything, right? Give me a second. No, I won't show you anything, sorry. Yeah, it's not about coding. It's never about coding, not only about coding. Because different frameworks like TensorFlow, Keras, PyTorch, scikit-learn I showed you. And you will see how easy it is actually in the coming days. Oh, okay, I see a huge question here. How do you solve that? You can read it out, if you want.
Okay, so hi, how do you solve problems with AI when much data is not readily available? The 3 example, it shows data can be generated, but I'm not sure if it is applicable outside NLP applications. Can you give more examples of how correct data may be generated to solve problems without much data?
Actually, that's a good question. I'll start by answering the first part of it. How do you solve problems with AI when not much data is available? Do you remember we have talked about clustering? That's one way of solving this problem. Again, for example, in internet, you can find so many photos. Let's take example of photos, right? It's always not labeled, right? You have a photo, but you don't have like a label for it. So what do you do in this case? You try to cluster the data. You make some kind of assumption. How many classes do you have in this data? Cluster it, and then you try to label the clusters themselves, and then you can, like, for example, have some kind of statistical evaluation. How many data was mislabeled? was labeled properly. And then if you have enough data from this kind of stuff, you can get it for example, for classification or regression. From the GPT-3 example, it shows that data can be generated. You see, GPT-3, I wouldn't always use GPT-3 as data generation. It actually can be used. I have done it myself for my project. It would be easier to get the data, labeled data from GPT-3 than doing web scraping and actually getting data from internet. But in case of NLP problems are mostly solved by scraping the data out of internet and properly labeling it. For you have Wikipedia, which is a huge source of data, which is actually quite cured data, which means it already has some kind of filter on top of it. In many cases, like 95, let's say. So you can take data out of this. You can take data out of Reddit, which GPT-3 was actually, if I'm not mistaken, Reddit was one of the data sources for GPT-3 training. Again, I might be mistaken for something else. And can you give more examples of how correct data may be generated to solve problems without much data? Can you give more examples? Okay, let me think. Can you give more example how correct data may be generated to solve problems? Again, web scraping. I would say relying on. You can conduct some kind of surveys. But yeah, actually, getting data and data labeling is one of the hardest problems. And there's like no simple answer, but just for starters, you can use internet with random search, with some searches. You can use images. You can use already available data sets. Of course, right? We have websites like Kaggle, like scikit-learn, the framework I was using beforehand, has also a lot of data sets included. Yeah, that's actually a great idea, which we will talk more about during the second and third lecture, if I'm not mistaken again. I hope I answered your question. If not, I can do my research and answer it in more detail. Yeah, do we have any other questions?
Yeah, we have a couple of more questions. So someone is asking in the chat, so basically AI is more of machine learning?
Okay, is AI a machine learning?
No, so basically more of machine learning. I think what he means is like if we talk about AI, we mainly talk about machine learning.
Do we talk about the question from Osei?
No, from Salim.
Okay, okay, I don't see the question. Of course. So basically, is AI only a machine learning, right?
No, I think like maybe I can also just take this question.
Yeah, of course.
So maybe nowadays, I mean, there are, of course, machine learning is, I think, like nowadays the biggest part of the whole AI field. But there are also, like David mentioned previously, and there are still some like non-learning AI methods which are all still used and also popular. But I think there's something called deep learning, which made like the whole machine learning field quite popular. And nowadays, the majority when you talk about AI is basically machine learning.
Yeah, like Daniel told before, just told you, it wasn't really popular to use machine learning and deep learning. Deep learning is a type of machine learning, so to say. It wasn't really popular. It just because of the great expansion of computer resources, we can actually do optimization on the greater scale with the help of GPUs from GPUs. I mean, better CPUs more RAM, which is also really important not to get bottlenecked during the training. And some giants like Google, Facebook, they have almost infinite amount of those resources. And that's why you can see a lot of state-of-the-art models coming from them. But yeah, again, AI is not only machine learning. It is much more than that. It is also there are like many approaches to AI, not just machine learning. Yeah. Do we have any questions?
Yeah, we have more. From Slack, we have from your presentation, the quality of the output of an AI model relies heavily on the quality of the input data. So besides the quality of the input data, what other factors generally affect the quality of output of an AI model?
That's a great question. I would say the model itself plays a big role. And what model do you actually choose? For example, we had an example of, I don't know if my slides are showing right now to you guys. If not, I would like to ask you to do so. Give me a second. Yeah. Principle of called model overfitting in AI, in machine learning in particular. When you try to use a powerful model for a not as powerful data set, so to say. Like in this case, we have area and price in dollars. And as you can see, a line is sufficient in this case, I mean, to some degree, right? But for example, if we would use deep learning, which is deep neural networks, which is part of machine learning, we would have something like, show you actually. Hope you can see my screen now. Oops.
Yes, we can see it.
Yeah. So as you can imagine, like this black line would be sufficient enough, right? But if we would overuse a more hard but more powerful model, it would try to adapt as much as possible, which is not great in this case because we can see that, for example, this red dot, they are just outliers. And basically, two things you have to take into consideration. The first one is data itself. Do a lot of data processing. Check your statistics of your data. Is data balanced enough? Does it have all the classes you need? Are the classes represented equally, to some degree equally? And then take the look of the model you are using. We have support vector machines, a different, I don't know, what can I say? Random forests. We have neural networks. Neural networks are actually quite overfitting if you don't have enough data. So yeah, I hope that answers your question. Again, if you would need more detailed answer, I can answer you in the private. Yeah, do we have any questions more?
Yeah, we have a lot more questions. Okay, so from Teams, from Akwasi, I hope I pronounced the names correctly. If not, I highly apologize. What is the best way to clean data?
There is no. The best way is to check every instance, which is not feasible, as you might understand. I can give you an example. You can't check the whole Wikipedia. It's just not possible, right? You have to do some kind of statistical evaluation about the data representation. You have to check whether your data is it actually good, quotes unquote. Does it contain any explicit content? You can do for example, actually for NLP, you can do a pre-processing with just general code. Like for example, if there is explicit content, delete the paragraph or delete the sentence from the data set. Yeah. And again, images. Do clustering. Try to use try to do statistical evaluation of each cluster of each class. Yeah. But I guess we can leave more links on this, right, Daniel, afterwards, because it's a huge topic, the data.
Quite difficult, and also really depends on what kind of data you're working with, because for images or videos, it's completely different than for text. Yeah, we can look for more resources on that and put it on the Notion page.
Yeah.
Okay. Next question
Sorry to interrupt you. I want to say you that we have how many minutes left? Many minutes left, guys. So yeah, let's be quick with it.
Yeah. So from YouTube, I think this refers to the GPT-3 example. Before outputs are made, does it require training before automatically generates the outputs?
Could you repeat the question? Sorry, I was distracted for a second.
Before outputs are made, does it require training before, or it automatically generates the outputs? GPT-3.
I got you. Okay, this is actually an example of what's it called? One-shot learning. The idea is simple. Is quite simple. You have a huge model which was pre-trained on a lot of different data, which could be unstructured, which could be covering different aspects. For example, one model could be for different NLP tasks, and then, like in GPT-3, we would have a one sentence describing what we need to do, and based on all information they have learned before and the sentence you just gave it, it tries to adapt to it. It's called one-shot learning because you don't give it a lot of data. You basically give it one data point, so to say, and based on this, it can generate a lot. I think I answered this question, right?
Yes. Okay, so there are some questions regarding IDE or device for this course. I would not cover this now, especially because you don't need high-end devices, because we will work in the cloud. And IDEs, same thing. We will use something Google. Yeah, and also there was another question regarding more resources for AI. We will post more resources for you to learn about AI after the lecture. But there's one more AI question. Can you use more than one model to get a desired output?
Again, great question. Yeah, why not? It's called assembled learning. I won't dive deep into details right now, but basically the idea is the following. You have multiple models. It could be different models. For example, it could be two neural networks working on the same. You train them on the same data. Again, it depends on your task. And then you build like a small model on top of them, which decides when to use which model in each case. Again, it's a very simple example. It's a very diverse field, assembled learning. But my question is no. My answer is no. You can use more than one model to get desired output. Maybe you want to add something, Daniel, to this?
No, I think you explained that.
Okay.
Or also another possibility would be to just use not like ensemble learning, but just to have an ensemble where you have multiple models which are trained on the same data set, but they are initialized differently, or they also might see some different kind of data. And then you basically also use something like a majority vote for the output.
Again, it has a lot of different applications, types, and it's basically more common to use more than one model to create one huge, so to say, in the end.
Yeah. Okay, I'm checking for more questions. There's one in Teams, but this is also for this was I guess answered like with the whole ensemble stuff. What did you say?
We have another 10 minutes for the questions. I mean, it's a hard limit for the interview, or not interview, stream.
Yeah. So there's one more from Slack.
Mm-hmm.
My understanding is that regression supervised results in a mathematical equation, which is the model f of x, e.g. I think it means equals or greater or equals polynomial.
I think it's example given.
Or example. Oh, okay. Polynomial. Yeah, I don't understand how models from sophisticated examples like semantic segmentation really look like. Also just mathematical equation or something else?
I mean, it's at the basics, everything in machine learning is a mathematical equation. But yeah, to be honest, no. How models from sophisticated examples like semantic segmentation really look like? That's a great question as always, but I don't think I can. I'm not really an expert in this field. I can give you an overview how it actually proceeds. There are actually different methods how we can tackle data, different models we can use. For those like huge tasks like segmentation, object detection, we use neural networks most of the times. I would say 99% of the times. And it's basically, we'll give you information more about neural networks, but there is this kind of layers in neural networks called, how's it? Daniel, I forgot the name.
Do you mean convolution?
Yeah, thank you. Yeah, convolution layers, right? And they kind of simulate how the eye of human works to some degree. I mean, and it's based on a lot of research in computer vision, because computer vision it's not just deep learning and machine learning. It's also a huge field on its own. So deep learning, so machine learning adapted some of the tactics, including convolution layers, to tackle this problem. But in general, these models can take up to billion parameters, and I think even this year, there is this new model which has 1 trillion parameters. And I mean, you have to really like dive deep into how it works. And not every person can actually, not everyone, and I think almost no one can explain how some of the machine learning models work. In particular, neural networks, because there is this field of AI called explainability of AI, which is doing a lot of research right now, and I think it's an important field on its own, which tries to understand how these neural networks, like these machine learning models, learn, how they do this, how with the help of optimization, how do we get these results, how do we get these parameters. I mean, I'm simplifying the words, the terms, but I think you get the idea. Again, we'll do some research as well in post.
How is it time-wise? Do we have time for more questions?
We have time for 2 questions.
Okay, cool. There are 2 more questions, and then other questions, please just write it in Slack and we will answer them. Okay, the first question is, can you use AI to mimic human and animal behavior?
We are trying to. I mean, at least clever people trying to. Yeah, we have talked about reinforcement learning. This is the closest we have to behavior. So yeah, for example, you have seen, I guess, from Boston Dynamics, some robots which like do some kind of stuff. They are actually not completely AI based, not ML based actually. There's some also what's called programmable AI in it. So it's basically predefined somewhat. But a lot of reinforcement learning in robotics, and they try to simulate simulate human behavior, but I think we're having great results, or like decent enough to mimic human behavior or like any other animal behavior.
Yeah, also I can also add something to that. Also, like today when we talked about computer vision and NLP, like all these tasks like object detection or also text classification, sentiment analysis, this is actually also already kind of a human behavior in a very simple way. So we actually already have that here. Yes.
Yeah, good point.
So last question, can there be 100% accuracy in outputs, or is there always a small error we can't deal with?
For example, if you have one class and the data is consisting only out of cats, yeah, I can say you have 100% accuracy. But no, I would say even if it shows 100% accuracy, it also has this such a small fraction of not being sure. I mean, when you have more than one class, obviously, but yeah, I think there is never 100% accuracy. Maybe it's a biased opinion. Daniel, what do you think?
No, I don't think that there is 100%. Also because you have to differentiate between like the training during your development and then like really using the AI in the real world, because there are always some completely new scenarios. For example, if you think about like self-driving cars, there are always like accidents happening because there are completely unfamiliar scenarios they have to deal with. And yeah, that's also a reason. Yeah.
I mean, even in real life, you can't achieve 100% accuracy. How much would you try? You can't do this just because of a quantum stuff.
Yeah.
Really, very
Even also for humans, it's sometimes impossible to get 100% accuracy.
Yeah. No, my answer would be no.
Yeah.
I mean, we have time for one more question. If we would answer it in 2 minutes.
There is one more question, but this goes more into the details of convolution. So I would rather skip this question and kindly ask you to repost this question then rather in the Slack channel.
Are you talking about understanding of regression?
No, convolution.
Okay, then never mind.
Yes.
We don't have time for that. There is this question, please. Do we also represent data as a function AI? I mean, in machine learning, that's the idea of machine learning, as far as I'm concerned, to represent data as a function. But again, a function model, it's used interchangeably.
And maybe also just one thing from my side. I mean, the data is not represented as a function. The data is represented as the input to a function, and your algorithm is basically a function.
Yeah, I would say it's okay. Yeah, good point there. I guess, yeah, basically your algorithm is a function, is a model. So these are like interchangeable words to some degree. But data is data. You give data to the model, algorithm, or function, which is again interchangeably used, and receive different outputs. Right? It's always based on your defined task. In clusterization, you just want to know to which cluster is the data corresponding. Yeah. And classification, to which class. In regression, you just want to give the next. You just want to have an output without class predefined. Yeah. I think that's it.
Yeah, that's it.
Then final words from me. Thank you, Daniel, very much for moderating this, for answering questions. We will see you guys, folks, during this week and during the next week. I'm really looking forward to the presentations from Flora and Patrick. A lot of cool information is coming and stuff. So be sure not to miss it. And we will keep you updated. I guess that's it from my side.
All right. Have a nice evening, guys.
Yeah, have a nice
Thanks
evening.
Thanks for joining.
Everyone. Bye.